Hello, this is Alden Mitchell. This is a problem I had a decent amount of trouble with. I believe it was mostly because that there was lots of data given and there was some difficulty with the data. In this problem we are given this graph where the air velocity is flowing in and then flowing out over here. We are given the air velocity at multiple heights on both sides and told to find the air coming in or out at the top or bottom. To do that, we assume that the air is conservation of mass, and also conservation of mass flow rate, which will give us the equation m dot in equals m dot out plus or minus, because we are not sure whether or not the air is flowing in or out, of m dot top and bottom. To find m dot out, we use the equation rho times the velocity in times the height. The reason we aren't using area in this case is because we can assume a length of 1, so the only variance is the height, and the length will cancel out when we get to the other part of m out. And m out is solved in a similar way. A of rho v out times h. The difficulty is finding v out. For that we use the average of the data. There was some difficulty in finding the average because the data given ranged from negative 6.5 to 7.9, which is against with what we were given in the photo, which goes from negative h to positive h. So I use the data from negative 6.5 to positive 6.5. Using Excel to find the average, I got an average of 10.73. The difficulty with this is the average used in the solution was 10.28. This is different because the average for this was taken from negative 6.5 to 0. The numbers weren't symmetric from 0 on both sides, but I assumed it better to take the average of the whole thing over half. Half. Okay, so going back to the m dot in or m dot out, we can then rewrite the equation to be m in minus m out equals m dot top and bottom. Because rho and h are in both of them, they can be taken out of m in and m out to be rho times h times v in minus v out equals m dot top and bot. Plugging actual numbers into this, the density of air, which is the thing that is being flown through in this system, is 1.25. Because we use the distance from negative 6.5 to 6.5, the total height is going to be 13 times v in times v out. The average velocity in is 10.5. V out is going to be 10.73. Because this number is negative, it is showing that air is flowing into the system. That equals m dot top and m dot bot. This turns into being negative 3.737 equals m dot top plus m dot bot. Because in the problem it says that we can assume the experiment is symmetric, and so the mass flow rate at the top and bottom are the same. It's not symmetric because the average from negative 6.5 to 6.5 is different than the average from 6.5, negative 6.5 to 6.5. They should be the same because it should be, the two averages should cancel out. But anyways, we can tell that M top equals M bot. So if we, from this, we can assume that they are the same. So negative 3.75 divided by 2 equals M dot top equals M dot bot. And that is a total of negative 1.868 kilograms per second. That is the mass flow rate in and out of the top. Actually, because it's negative, it's the mass flow rate, the flow rate in of the system.